Hello viewers, welcome to my channel Connect Civilians. So in this lecture we are going to see how to design a combined footing for a column using the Excel sheet. So two columns will be added for this combined footing and both the column are square, and these are the initial values you have to provide for the column first and column second. Here you can see in the figure also both the columns will shown under the footing. So this will be the plan of the footing and this will be the plan of the column. Okay, so here you have to change the values that was in the colored box only, and another value will be changes according to that. Okay, so this will be your P1 load, that is load on column first. So here our load is coming as 600 kilonewton, so we are going with 600 only. Our SBC is 250. Okay, so these are the initial design values you have to fill by yourself for the design of the footing. Okay, these values you can also get from the stud if you have all the data and the action from the building of superstructure. Okay, this so our SBC of the soil was 250. Column size is 400 by 400, that will be okay. You have to change here only, that if you change 400 here, it another size of the column will automatically changes by 400. Similarly for column second, here you have to change the values. Okay, so our load is for column 2 is coming as 800. Column size was 500 by 500. Okay, sorry, 500 by 500 we are going. If you want to change the size to 600, you can do it. Okay, so okay, we can take the size of the column as 600, and our column to column distance. So what will be our distance of under the both the columns is coming? So it is coming as 4 meter. Okay, so this distance from center line of first column to center line of second column, this distance is 4 meter and it should be known. Okay, at how much distance your column will be present on site. Now we have to fill the unit weight of the soil. So here we are considering 18 kilonewton per meter cube. Depth of the footing, so this depth of the footing is the backfill depth on the foundation. Or okay, so you can consider according to value. Okay, our depth we are considering as after 1 meter your footing top will be started, so we are considering the depth of the footing as 1 meter. Okay, so this is not the depth of the footing but the depth of your backfill. Okay, so grade of the concrete for footing will be M25. We are considering M25. And grade of concrete for column, so what grade are using for the filling of the column? So here you have to give that value. Okay, so we have taken M20 for column. Grade of steel is 500, and your percentage of self weight of footing we are considering as 10%. That will be okay. So you can also change to 15 if you want, but we are for initial values we are going with 10%. Now your self weight will be calculated. Self weight of the soil, total load including self weight is coming as 1540 kilonewton. So these all values that were not colored will be calculated by itself. Okay, only you have to change the colored values. Okay, area of footing is coming as 6.16. So if you consider the width of the footing as 2 meter. Okay, so this will be the, if you see the figure plan of this, so this will be your width and this will be your length. Okay, the longer side in x direction is length. Okay, and the shorter side is width. So if you consider the width of the footing as 2 meter, that will be okay. Or if you consider 1.5, so length will changes to 4.11. So if you consider 2, so length will changes to 3.08. So here you have to input the final size of the footing. Okay, so width will be 2 meter and length, if you consider it as 3.5, that will be okay, because our calculated value for the length of the footing is 3.08. So we are going with the greater value for safety in one way and two way. Okay, check. So now our provided area is coming as 4 meter square, which is greater than our calculated by the formula. So this will be okay, and you have to check all the red boxes whether it was showing you okay or not. See, if it will show you not okay, again you have to increase the size of the footing. Okay, now this will be okay. Now you can go for further step, that is a net upper pressure. So it will be calculated, and this will be your total load on both the columns divided by the area of the footing. Okay, that we have provided. So our SBC is coming as, our net upper pressure is coming as 200, which is greater than less than our SBC of the soil. So this will be okay. Now gross soil pressure. So you can check your gross soil pressure after the defining the total depth. Okay, you don't have to see whether it is okay or not right now. After defining the depth, you can check. Okay, the further step we can go. So bending moment and shear force. So it will be calculated in x and y, and your shear force and critical bending moment, where it is coming, all the bending moment for column 1 and column 2 at the left side of column 1 and at the right side of column 1, at the right side of column 1 and at the left side of column 2 will be calculated. Okay, so here we are not going to talk in detail about the bending moment and shear force. If you want the detailed description about the bending moment, how it is calculated, so you can comment me. I'll provide the manual calculation for the combined footing also. Okay, but now that will be okay. So here what we have to consider, we have to consider the CG of the footing will be equal to the CG of your column. Okay, so our resultant of load will be coming as 2.29. Okay, here if you see this distance, it is coming in minus. Why? Because we have taken the length of the total footing as 3.5 meter, and if you see here the center to center distance between the column, it is 4 meter. So that's why it is showing in negative, because our total length of the footing is equal to the center to center distance of the footing, which is not correct. So you have to give the higher value than this. If it is 4 meters, so you have to almost give 4 point, at least give 4.5. Let's go with 4.5. Okay, still you need the to increase the size of the footing. Okay, now go with 5 meter. We are going with 5 meter. Now the value come in positive, so this will be okay. Okay, so you have to check all these values, so it should come in positive, otherwise your footing face will coincide with your column face. That is not correct. Okay, so you have to require some amount of space uh, at the left of the column 1 and the right of the column 2 for the safe check for of one way and two way. Okay, so now this will be okay, so you can further move. and your bending moment and shear force value is calculated here. Your critical section at the face of the column 1 in y direction, okay, is coming as 700 mm. Sorry, for column 1 it is coming as 0.8 meter, and for column 2 it is coming as 0.7 meter. And your shear force at left of the column 1. So this is the shear force diagram. So I mentioned all the diagrams here for the shear force. So this will be a column first one center, and this will column 2 second center here, and this value will come. If you are going at the top, it will we are going to take as positive. If it is downward, we are going to take as negative. Okay, so shear force at the left of the C1 is coming at 90 kilonewton. Shear force at the right of C1 is coming as 810 kilonewton. So this value will be calculated here, and all the value will be mentioned. Okay, so shear force at the right of column 2 is coming at 870, and at the left of column 2 is coming as 330 kilonewton per meter. Sorry, kilonewton. And the bending moment at column A is coming as 9.68, and the bending moment at column 2 is coming as 129 kilonewton meter. And your critical bending moment is coming as 771.43 kilonewton, and it is showing in negative. Why it is showing in negative? Because it was a hogging moment. Okay, and hogging moment, if you see what happened, your footing will uplifted between the two columns. Okay, at the between the column 1 and 2, so that's why it was showing in negative. Okay, so only the sign denotes your uh, direction, either it is coming at downward or upward or anti-clockwise or clockwise. Okay, so you don't worry about the sign, you have to take the values only. Okay, so all bending moment and shear force for longer direction is calculated here. Further, you can go for depth of the footing check. How to, you have to fix the effective depth of the footing. Here in the diagram, all the value will be given. At what distance your shear force will be 0. So from column C1, the at 1.93 meter distance, your shear force will be 0. For column C2, the distance is 2.07, and the resultant of load is coming at 2.29. Now this will be okay. Here you don't need to change anything. Further, you can proceed further. That was the footing. All you need to do, you have to just check all the values, either it is correct or not, or it is coming or negative or positive, as I've shown you in the figure for this. Okay, now you're bending your effective depth calculation. So we have taken the FE 500. So if you follow the SP16 code, so this value will be taken from there, and it will automatically change in this. You don't need to change any values here, and you have to check what your effective depth value is coming as 341 mm. Now you have to provide the overall depth according to your effective depth that is showing here. So I recommend to take the higher values. Okay, 30 to 40% higher value than the calculator effective depth, so that will be safer. So our effective depth value is coming at 341 for the maximum bonding moment, which is coming at shear force, where shear force is 0, that is 771.43 kilonewton meter. So you have to insert the overall depth. Now we are going with 450 for now, and we are taking the cover as 50, and the dia bar of first layer, so you do need to change this value here. What you have to do, you have to first just check what effective depth is coming, and here it is safe or not. So here it is okay. And in the reinforcement design, you have to fill your dia bar, what dia bar you are providing for hogging bars and the sagging bars. Okay, sagging bar and hogging bar, where hogging is happening, that is at the middle of the column C1 and C2, between column and C, and the sagging is happening at the left of C2 and at the right, at the left of C1 and the right of the C2, column C2. Okay, so our effective depth is coming as 392, and this will be safe as our effective depth is 341. Here we have already inserted the bar diameter of first layer and second layer, so this will be your bottom bar dia. Okay, always remember that is the lower bar that is coming here, that is the orange bar, and this will be your second layer bar, that is green bar at the lower position. Okay, so when you design this bar, you have to provide the dia bar according to this, that. Okay, so here your effective depth will be okay, and we can go for the reinforcement designing. So first we are going to design for the reinforcement for the hogging moment, that is reinforcement between at the top between column C1 and C2. Okay, so you can provide the at the top for the whole footing. So I will show you in the figure for what bar I am talking about. The top of the orange bar. Okay, this will be a top bar. So this will be bar will use for the hogging, that is where the tension is coming. Okay, so first we design that bar. Now for that bar we are going to take the value for the hogging moment. So our hogging moment is 771.43 kilonewton meter. So that value is taken here, and your percentage still is coming at 0.666. Okay, so and here your width is 2 meter, your effective depth is 392, that is coming here, and here you have to only insert the dia bar that you want to place. Okay, so right now I am going with 25 mm of dia bar because our steel is coming is higher, so I am going with greater value. So this will be a AST coming, that is 5221 mm square, and this will be your AST minimum, that is 1080. So this value will be greater, that will, so we have to consider this value. So it will automatically consider, I was just guiding the what value the software is taking, that is the maximum value. If it is less than your AST minimum, so this value will be taken by software. Okay, now number of bar required is coming as 11. Okay, so you have to just provide number of bar that you want to provide. So either you can go with 11 and check either it was showing you okay or not. Here it is okay because our area of bar is coming at 5397, which is greater than 5221, but for spacing here it was showing you not okay. So again you have to increase the number of bar. Now we are going with 12 number of bars. Now it is okay as our clear spacing is coming as 145, which is less than 150. Okay, as per IS code that was mentioned. So you have to, for FE 500 you have to provide the spacing less than 150. Okay, now this will be okay. So and this 188 mm is your spacing that is coming required after dividing the area of ST required by area of steel provided. Okay, and we are providing lesser than this, that will be also okay. So we are providing 12 mm bar at 145 mm center to center for the hogging steel, that is at the top of the footing, for the orange bar at the top, and here it was shown in your figure also. Okay, not 12 mm, we have taken 25 mm dia bar at 145, sorry, 170 center to center. So you have to give the value for center to center spacing. Okay, so 25 mm dia bar we have taken at 170 center to center. Here in figure we have mentioned 25 at 170 center to center. Okay, so this orange bar we have taken. Okay, so we have given 25 mm dia bar at rate of 170 mm center to center, this top orange bar. Okay, right now this will be okay. Now we can go for the design of bottom reinforcement under column 1 and under column 2. So this here we have to consider the sagging moment. Okay, so our moment and the column 1 is coming as 9.64. okay, so here that value will be taken. If you see here, it will be converted into Newton mm. So this will be okay. Our percentage of steel is coming at 0.007. So I will again mention, so you have to provide 0.12% of the gross area, that will be the minimum steel you have to provide if you are using HVSD bar, and if you are using the mild steel bar, so you have to provide 0.15% of the gross area. Okay, so now with this taken as 2 meter, effective depth is 392, and dia of bar here you have to mention. So again I am going to tell you one thing, you have to provide the same dia of bar for bottom reinforcement under column 1 and column 2, then your effective depth value will be correct. Okay, if you provide 20 mm dia bar under column 1 and 60 mm bar or under column 2, so that will be more complex in the calculation of one way and two way check, where effective depth is different for the both the columns. Okay, so just provide the same dia bar for more simple result. Okay, so this will be the bottom reinforcement, the orange bar under column 1, and this will be the bottom under column 2. Okay, so that will also depend on the load, what load is given, or you can just follow the all the bars at the same spacing. Just here you have to check what maximum spacing is allowed. Okay, so now this will be right. Again you have to put the dia bar. So if you go with 14, your effective depth will be changed as 393, but I am going with 16 only. This will be okay. 5 number of bar will be calculated. So our ST required is coming as 57 mm square, which is less than our ST minimum. So software going to take 1080 mm for the design consideration. Okay, number of bar is calculated as 5 number. So we are to provide more than 5. Let's go with 6, but always check this also not okay. It is showing you not okay. It is showing you go with minimum. Okay, so software going with go with the minimum bars. It is okay right now, but here spacing will not okay. So again increase the number of bars. 7. It's still showing you not okay. Increase number of bar. 8. It's still showing you not okay. 9. And again you have to increase until when it is showing you not okay. Go with 12 number of bars. Now 30 number of bars. Now this will be okay, because our center to center spacing is coming less than 150. It is showing you okay. So 30 number of bars you have to provide under the column 1. So this will be of dia of bar at 16. Similarly you can go for bottom reinforcement under column 2. So moment is taken for column 2, percentage coming 0.009, width will be 2 meter, effective dash 392, die of bar, just take the same die of bar, again I am repeating what bar you have taken for 16, column under column 1 you have to take that. If there is much difference in the moment, then you can go with the different die of bar, but that will be, if you are going with same, that will be more uh, easy in the design consideration. And as per the site condition also, because different bars will be provided in same footing, that will be more complex and time taking for the site consideration also. Okay, so now this will be at, I'm going to take a 60 mm same ST coming as 776, minimum is 1080, go with minimum. Again number of bar is coming as 5, so again we have to provide 30 number of bar, as spacing will not going to pass, so you have to provide 16 mm of bar at 157 mm center to center of spacing. Okay, we can also check in 16 mm of bar at 157 center to center of spacing, 16 bar and 157 center to center of spacing under column C1 and C2, and remaining portion that is coming you can go with AST minimum. Okay, this value will be taken as the AST minimum. So if you want to provide, go with much easier, because AST minimum is also coming as 16 mm at 177 center center, that there is not much a difference. You have to minimum, there will be 2 or 3 bar will be increases, so this will be okay. So you can provide a thorough state reinforcement at of 16 at 157 mm center center for the at the bottom for the whole footing. Okay, the orange bar at the bottom. Okay, that will also be okay, but you can't provide bar the say more than this spacing that is provided. Okay, you have to go with lesser of these values. Okay, now your top hogging and bottom reinforcement under column 1 and column 2 and minimum reinforcement is calculated. Now we can go for the calculation for the transverse steel. Okay, the steel that is coming in y direction, that is in shorter direction. So here what you have to do, we have to first consider the width of the central bandwidth. Okay, what will be the width? So if you see the footing, we are going to find for the green bars, that will be a transfer steel. Okay, at the bottom, at the top. Okay, so first we would find at the bottom, and at the top you can go with the ST minimum for the green bars. Okay, directly, you don't need to be confused. So at the bottom, if you see this will be your center band under column 1, and this will be center band under column 2, that is value that is here 1152 from the center on both the at the left and at the right side, and 1352 from column center at the left and the right side. Okay, so here you have to consider dia of bar. So what we have done, I already told you, go with same dia of bar for whole footing at the bottom. If lesser value is coming, then you can go, but if value AST value will be coming nearby same, so you go with the same dia bar, that will be much easy for the side consideration. Okay, and that will also depend on you what availability is present on the site that was you are working. Okay, so I'm going with 60 bar, so effective depth is coming as 376 here for y, if you see 376. Okay, so our center bandwidth is calculated according to this affected, so it is coming as 1152 Upward pressure is coming as 450 kN per meter. Bending moment at face in transfer direction. So at face of the column it is talking. Okay. So it is coming at 144 kN meter. Now percentage still is 0.21 is coming. AST 919, your minimum is 622, that will be okay. So our area of the 16 dia bar is coming at 200.96. Number of bar required is coming at 5, and number of bar what you have to provide, you have to just change that. I'm going with 11 again. Okay, go with uh, so spacing is less, so I'm going with 8 right now. Okay, go with 7. Let's see. Oh, it will showing a not okay. So go with 8 bar, number of bar. Now everything is okay. So everything will be saved according to design consideration. So this will be the steel in transfer direction under column C1 is calculated. Now go for column C2. Okay. Die of bar you have to consider 60 mm die of bar. Upward pressure is there. Everything will be same. Again number of bar is required is coming. Now you have to again increase as it was showing you not okay. 9 number of bar. This will be okay. So under column C2 is you have to provide 9 number of bar of dia of 16, and your remaining portion for the transfer stereo calculation dia of bar you have to provide here. Number of bar is coming 3. Again you have to increase number of bar at which it was showing not okay. Go with 7. This will be okay. So you have to provide 7 number of bar at the remaining portion of 16 mm dia of bar. So first you will see under column C1 what value you have taken. 16 mm dia of bar at 148 center. Let's see the figure. So this will be the bar under transfer steel under column C1 60 mm dia 148 center is coming. So this will be say okay. Under column C2 it is 16 mm dia bar at 155 mm center. Let's see 16 mm dia bar at 155 mm center. This will be also okay, and remaining portion is this 16 mm dia at 147 mm center. So 16 mm dia at 147 center spacing. So this will be also okay. Right now we are going safe. Similarly UST, if you want to provide the transfer steel at the top also, so you can go with 16 mm of dia bar at 147 mm center to center. Okay, for the transfer steel for the whole footing at the top. Okay, you don't need to provide as same that you provided at the bottom. So this green bar at the top you have to provide 16 mm at 147 center for the whole footing. Okay, now your reinforcement is calculated for at the top and the bottom. Now we can also go for one way check. Okay, so we have done for both the columns. You can go for with the heavier column also if you want, or you can go where the your property line is closer. Okay, so we are going with both the columns, so you can check for both the values. The effective depth for under column 1 is 392. So effective depth will be same as dia of bar we have taken, same for column 1 and column 2. Okay, width will be 2000. VU ultimate is coming 561. Nominal share is coming 0.716. So here you have to mention again, you have to use the code IS code 456 of table 19 for Tausi values, or you can, if you do not have the code, so here we have uses the formula from SP16 code. So directly from SP16 code it is calculated. If you don't have the IS code 456, then you can just see here that it is showing you safe or not. for one way shear. Okay, so here what is happening, according to SP16 this value will be calculated. So shear strain of concrete is coming at 0.64. It is not safe because our 103, that is 0.64, is less than 0.716, that is nominal shear, so it will be not safe. Okay, or you can also check with IS456. You have to change this value from the code after the interpolation, using the interpolation. We have already talked in previous lecture of footing design for the uh, single footing, step footing. Okay, if you haven't seen that video, you can also check. We have already done that in that video. Okay, here we are going with SP16 directly. I am assuming I don't have the code, so we are going with this. That will show you not safe. So what you have to do, if you're showing you not safe, then you can also increase the depth of the footing or size of the footing, or you can provide the shear reinforcement. Okay, so for footing what you have to do, you have to provide the 8 leg distribution always. Okay, so we are going to consider the, here it is showing you provide shear reinforcement, here it is showing not safe, so you have to provide a shear reinforcement. Consider shear reinforcement, so we are going with 8 dia of bar at 8 legged, and we are using the grade of that step as 415. Okay, so our spacing is calculated as 1 mm, and our maximum spacing that is allowed is calculated at 181. And what we have provided, we have provided 100, we are going to 100 mm because our spacing is coming as 101. Here we have provided 100 and it is safe. So you have to provide your shear reinforcement under column 1 at of 8 dia bar at spacing of 100 center of 8 leg stirrup. Okay, so this blue line is your stirrup. Okay, now again also go with under column 2 also if you want. Similar procedure will be taken here, also showing you not safe. Provide the dia bar you want to use for stirrup. 8 leg we are going to use. Generally in footing you have to use the 8 leg of stirrup. Okay, so if you don't know what is 8 leg, we are going to also make a video on the stirrups also. Okay, so you can comment us, so we will provide that video as faster as we can. Okay, now our spacing is coming 98 mm, so we are going with 98. Let's go. We are providing 98 mm under column C2. Okay, so here see what happened. We have given the value for under column C1 also, but you have to go with the C2 also. Check where we have to provide the 8 mm of dia bar stirrup at 98 mm center to center. Go with safer value, go with 95 mm center to center spacing, so you can follow the for the whole footing the same value. Okay, for safer result, here we are going to change that value. Okay, we are going with what spacing is less, here it will show you. Okay, so 8 dia of bar of 8 leg stirrup you have to provide at 95 and center spacing. Okay, for the whole footing. So okay, so you check for one way and two way will be completed. Now we go for the punching shear. So here for column 1 and column 2, we both for both the column we have shown you, but you can go for the heavier column. So here the condition is occur when the column size is different for, and also the column load is different. So we are going with both the check on the both the columns. Okay, so affected depth will be here, and your value for column C1 and C2 will be length of the total periphery will be coming as 3616 here under column C1 and 396 under column C2. So I hope you know at what distance the one-way check will be provided and two-way check. So one-way check will be provided at distance t and two-way check will be provided at distance t by 2 from the face of the column. Okay. So both value, you don't need to change any values here. All you need to do, you have to just see that either both the value is safe or not. Okay. If it is not safe, then what you have to do, you have to increase the size of the or the depth of the footing. Okay. Or you can also increase the steel bars. Okay. Now they is a so two-way check will be okay. Now for check for transfer load at the base. So in combined footing, it is that much not necessary for the load check at the base, that is transfer load at the but we have done for both the columns here. Okay. So you can also go thorough through it, so value will be there. So for column 1 it is calculated. So here no double bar will be required for column 1, no double bar required, no double bar, so this will be safe. If it is required under column 1 double bar, so you have to provide the die bar here. According to that you have to give the value here. Similar procedure will be here for one way check. If it is safe, so still you have to provide the minimum reinforcement. Okay. Minimum stirrups. Okay. So similar for the transfer of load, if no double bar will be, so you have to give the minimum number of double bar. So if you go with 20 mm double bar, so go with 16 mm double bar. So you have to provide the 4 number of double bar under column C1. Okay. This will be okay. Your final weight of the footing will be okay. Here if you see your final weight of footing will not okay, then you have to increase the self weight percentage at the top. Here self weight of footing, that is 10%, you have to increase to 15%. Okay. If it will show you not okay here, it is fine, that will be safe. Now we can go for column C2. Similar procedure will be followed. No double bar needed, no double bar, that will be okay. And here you have to provide minimum dial bar about 60 mm dial bar, so 9 number of bar you have to provide. Okay. Or if 9 number of bar is congested, then you can go with 20 mm dial bar, only 6 number of bar you have to provide. Okay. So 6 number of dial bar of 20 dial you have to provide in the column C2. Okay. So this will be a minimum dial bar you have to provide. Okay. If it is not okay, no dial bar, so you have to provide more bar for the safer value. Okay. So it will show you here either it is safe or not. You do not need to pen. All you need to do, you have to just insert the die of the double bar you have to provide. Okay. This sheet you can use for interpolation values. Here we already done the interpolation in previous class, so you can go and check. Okay. All the footing playlist you can check. Here it is development length. So calculation what die of bar is coming from the color, you have to insert that. And your percentage, so we are using HVAC bars, so we have to increase up to 60%, so 1.6. LD is coming at 906 mm. Side cover is 50, so our available length is 1026. This is sufficient for the development length, and our design is complete. And you have to just see the figure. This will be your double bars that is coming from the column. This will be your plan of the footing. This will be your reinforcement detail that you have to provide. This will be the double bar, the stirrup that you have to provide for the shear consideration. And here your table is also given, what overall depth is considered, what is the cover, what is the dia of bar for the bottom layer of main and transfer steel is provided, and longitudinal reinforcement and transfer reinforcement detail will be given here also. Okay, if you check, you can also find here, or you can directly find data from the diagram. Okay, so here we have followed all the procedures step by step for the design of the combined footing, where our corner distance, that is the from the face, was not provided. Okay, so we will also see in future where this distance is given, or there is value that is footing is coming after that also, or there is a wall, so you can go beyond that value. So what will how we have to calculate that, if this value is fixed. Okay, we can also check. Okay, so right now this will be completed, and if you like this video, please subscribe to my channel and share this video. And if you want to download the Excel sheet, we provide the link for that also. So this will be the so this is the save file. You don't, if you want all the uh, file unprotected files, so you can also download. I'll put the link in the description. Okay, thank you.